Uh, Once some of the code is progressively written, debugging the process may be the second step. And if you have something that is not behaving that you expected, you need debugging tools to do that. And over time, the code might grow complexity, use third-party libraries, etc. And the application could be, unfortunately, crashing. So there is a need to analyze crash dumps, either during development in the field or after deployment of the application. And hopefully you are not stuck in this category, in this part, and instead you need to investigate why the performance of the application is not as great as expected, or you simply would like to improve it. So then you need the tools to profile your application and get the performance of its different parts. Again, as mentioned earlier, this is very high level overview. I think I use like simple arrows from one part to another, but arrows can exist between all the parts of this workflow. And here we are representing both compute and graphics pipeline or workflows. But in this talk, I'll be focusing on the left part of this workflow that is more compute oriented. So what are the product or the tools that NVIDIA is providing to cover these different steps? So first, regarding the IDE part, we have integration into very popular IDEs like Eclipse and Visual Studios that enable these IDEs to become CUDA aware. And I will give some example of what that means later in this talk. Regarding the debug part, this integration also provides the debugging scenarios. And also we have command line tools like CUDA GDB and Compute Sanitizer that I'll be presenting later for memory related issues. These debugging tools can also help to view generated crash dumps as post-mortem activities. And for the profiling part, we have two main components. The first component is Nsight system, which is there to provide the system level profiling, as well as an application API traces in the form of very easy to use timelines table, and can also be used in the command line to dump the data to the console or export to a file. In Nsight system, you'll be able also to narrow down to what CUDA kernel or kernels or graphic workloads you need to be focusing on. And for that, after defining those kernels, we have Nsight compute that gives a better representation of the performance of those kernels. So here there are the recent updates that we have regarding all these tools. Of course, we have the full support of the latest generation of GPU, the Ampere GPU, with the newly introduced hardware feather that are covered now with all our tools. For example, the new FP64 tensor cores and the TF32 format that are now seen in Nsight Compute source view report. We also support the MIG or multiple instance GPU feature introduced with the Ampere architecture. We support acceleration of CUDA graphs, ARM server-based system architecture also supported, etc. So these are the recent updates. So regarding the IDEs, I will have a focus here on the IDE integration. So this integration means that IDEs like Eclipse IDE becomes CUDA aware in the form of being able to edit, build, debug CUDA application. So as you write code, you'll be able to see syntax highlighting for your CUDA sources, as well as code completion and inline help. Debugging becomes very natural because now not only you are able to do CPU debugging, but also now you can single step or set breakpoints or have a view of memory on the GPU side of things as well. And you can also do CPU and GPU debugging at the same time. So NVCC build integration is also available in the NVIDIA Nsight Eclipse Edition plugin. And it allows you not only to build for the x86, for example, platform you are running on, but also do cross compilation for other target platforms, for example, for Tegra. Something very interesting also provided in the last release is the Docker support that is available now. And for example, you're able to get some of the images from NVIDIA GPU Cloud, Docker images, and Nsight Eclipse Edition allows you to build CUDA project using inside these images. So you can mount the project source files from the host to the Docker container and build the project using the plugin and the CUDA toolkit available inside the image. So you don't need to have any CUDA toolkit installation on the host itself anymore. You can also do remote debugging of this application using Inside Eclipse Edition, which uses CUDA GDB on the cover. So we have very similar features integrated in Visual Studio as well. An extension to the Visual Studio you maybe use it to use. I won't focus on the features that are very similar to the Nsight, to the Eclipse Edition. But what is offered also inside the Visual Studio is the integration of different profiling tools like compute and system from Visual Studio itself. So once you have run a profiling session using NVIDIA system, for example, Nsight system, for example, all the settings stay on the same in the same place, and you can do a new low-level profiling of the kernel themselves with Nsight Compute without having to enter the settings again. So that makes it really easy. So again, now moving to the debugging part, CUDA GDB is a tool that you may use to see. So it's used from the IDEs, as I explained earlier, but it can be used as a command line. And again, it provides simultaneous CPU and GPU debugging and allows you to inspect and modify memory, register variable states of any part of your code. Support for multiple GPU is provided, multiple contexts, multiple kernel, and also can focus on single threads. New features since CUDA 11 are the upgrade of GDB 8.2. We also provide macOS X support as a host system, not as a running system. Many performance improvement. Module loads now are 30% faster, and also quality improvement. Another tool you may use for checking or debugging your code is CUDA memcheck, which is composed of different functional parts. So CUDA memcheck itself that reports out-of-band misaligned memory access, a tool called race check that identifies race on shared memories, a third tool called init check that checks the usage of initialized global memory, and sync check identifies invalid usage of synchronization point for divergent warps. So Compute Sanitizer is a new tool to check correctness we are promoting. It's on the long run, it will be a replacement for CUDA memcheck and provides many improved functionalities. It's still a new command line interface, and it provides important performance gain compared to previous CUDA GDB and other tools. So now we move to the profiler part. In the second part of this talk, we'll see how it works, and we'll have a demo of how it works. But here I will only mention the new features supported since CUDA 11 that are the availability of MPI tracing, the support of OpenMP 5 directives. So those are new features in Nsight system. And at the level of Nsight compute, we have, of course, the support for Ampere architecture specificities, like the use of compression units, for example, illustrated here, or asynchronous copy from memory. One important tool we are also very excited about introducing in this new release is the neurofline analysis that can be done in the GPU. So you can compare your kernel or your application versus the roofline that represents the limit of the hardware architecture you are using. This is a very useful tool when you are doing optimization. So I will be sharing the slides later, and I mentioned here very useful links to access if you want to go deeper in those topics. And now I hand it to you, Mohsen, for the second part of this talk about how to profile. So a deeper dive into profiling tools.